Welcome back. So this is lesson 6 now in our unit of polynomials. So we're going to look at factoring some of those special types of polynomials that I mentioned before. There's two of them in here. So difference of squares is the first one we'll start with. So imagine you've got a polynomial, however this time binomial. So the last couple of videos we've been looking at all the rules we can use to factor those trinomials into two things. But now let's see what happens when I've got a binomial. So a polynomial expressed in this format, x squared minus y squared. Literally that expression is a difference, subtraction, of squares, two terms that are being squared. So that's difference of squares. Okay, and this results when you multiply those two binomials together that are the sum and the difference of the same two quantities. So this is really what happens. Okay, so you can see the sum and the difference of the same two quantities, x and y. So for example, if I actually did the distributive property and multiplied this out, we would see that it is going to be x squared plus xy minus xy, and then a minus y squared. Now the reason why this is quite nice, those two middle terms of plus xy and minus xy actually are canceling each other out. So really, this is equal to x squared minus y squared. That's what we call it, a difference of squares. Now, you're going to really recognize that you have this by looking for a binomial, two terms. Okay, it involves subtraction, so we're taking them one away from the other. Now both terms are perfect squares. Now you may need to take a greatest common factor out first before you can see this. So we'll take a look at a few of these, and one way to factor a difference of squares is to insert a middle term of 0. So remember that there's always a middle term here because this is k squared minus 64. There's no term with a coefficient of k. Technically that's plus 0k. So we'll do this two ways to figure out what the pattern is. So, and then we'll factor it as a simple trinomial. So let's look at this one first. So for k squared minus 64, really that's the same thing as saying k squared plus 0k minus 64. So really what we're going to look for, if you remember all of our rules from our factoring video when a was equal to 1, so we're going to multiply to get negative 64, but add to 0. Oops, add to 0. So all the things that multiply to 64, 1 and 64, 2 and 32, all of those things working all the way up, there's a lot of possibilities here. Now if I remember that 64 is actually a perfect square, 8 times 8 will actually work. Now the only way I can add to 0 is if I have one being positive, one being negative. So that's going to be how we do this. Now let's do decomposition here. Decompose that middle term into those two pieces. So we're going to have a k squared plus, actually let's put the minus one first just by preference this time. So minus 8k plus 8k minus 64. Now remember that the negative 8k in blue plus 8k simplifies to 0k. They cancel out, right? So let's do some grouping. So k squared minus 8k plus 8k minus 64. There's my two sets of brackets. Now we can factor them. Common factor of k from the first one. So you're left with a k minus 8 plus 8 being the common factor of the second ones. So you're going to have again a k minus 8. So our brackets are the same. This is good. So our two factors, k plus 8 and k minus 8. Now that is exactly what those two integers are. So remember the shortcut from our couple videos ago. When you find those integers, as long as your coefficient of your squared term is 1, you can go right into the shortcut, which is really, really nice. So we'll do this maybe a little bit differently on the second one. We'll actually take a look at what the shortcut for a difference of squares is. Okay. Maybe I'll leave that one for you to try. We'll talk about it actually underneath. So again, just remember, as always, in that description box, you will get the full solution key. So you can try this one out, the 2k squared minus 18. Look for a greatest common factor first, and then go from there. So another way to actually factor a difference of squares is to square root both terms, then write two binomials, one with the sum of the two square roots, one with the difference of the two square roots. Because if you look at the shortcut we had above, really that x squared minus y squared is equal to these two factors. So if you look at it, it's x squared minus y squared. The binomials have only x's and y's. That's where the square roots are coming from. Okay, so if we square root the first one, square root the last one, place them inside with different signs, we're done. So let's take a look at a couple. 9m squared minus 16. 9 is definitely a perfect square, so is 16. M squared is also a perfect square. So remember, the square root of the first term, square root of the second term, and then the fact that they're being subtracted. So here's where we're going to make the difference of squares look really nice. So there's going to be our two factors. Now if I take the square root of 9m squared, we're going to get 3m. Okay, so 3m multiplied with 3m will give us 9m squared. Square root of 16 is 4. Okay, so there's the square root of our terms. One is a minus, one is a plus, and there you go, you are done. It is factored. You could have inserted a middle term of 0m, went through the decomposition process, but you would have gotten here anyway, so that's really, really nice. But this, again, is only helpful if we actually remember that the shortcut exists. Let's take a look at b. Okay, so now this time my variable isn't first, but that's okay. Right, as long as it's a binomial, I've got two terms. 81, yes, it's a perfect square, that's 9 squared. A to the power of 4 is also a perfect square because it can be written as a squared times a squared, if you remember back to exponents, right? Add the exponents together because I'm multiplying with the same base, that's a to the power 4. So this absolutely is a difference of squares. So we can write this as the product of two binomial factors. Square root the first term, 9. Square root of a to the power of 4 is a squared. 1 is a plus, 1 is a minus. Now here, it might be very, very helpful to actually look at those factors again. Because if I look, I've got 9 still a perfect square. A squared is absolutely a perfect square. Now, again, the rule is a difference of squares. So make sure that you're really looking for that subtraction sign. So 9 plus a squared needs to stay 9 plus a squared. You could rearrange it and do a squared plus 9 if you like, but there's nothing else we can do to it. There's no rule for a sum of squares, only a difference. So the second set of brackets is 9 minus a squared. Technically, we have another difference of squares that we can deal with. So I can take the second factor we had before and write it as, another difference of squares. Square root of 9 is actually going to be 3. Okay, so that goes in. Square root of a squared is a, that goes in also. Different signs in between, one a plus, one a minus. Now usually people don't like seeing the number first, they like seeing the variable first. So you can rewrite it, a squared plus 9, a plus 3, and 3 minus a. I'm choosing to leave the last one like that because really that's a negative. So you could factor a -1 out and have a negative sitting out front, so all of your letters are, the a's are first. So here's the other way you could write it. Okay, so if I factor a negative sign out of just the end one there, becomes a factor here, so I can put it in the front. A squared plus 9, a plus 3, and this becomes a minus 3. Okay? Either form would be correct. Totally acceptable. Here's my or. Okay? So that's the difference of squares. Quite nice if you actually remember what the shortcut is. Maybe we'll just take a look at, let's just take a look at, the last one here. And I'll leave the other three so people can attempt it if they want. So let's take a look at the last one. Now, we really have to figure out what our terms are. Again, I really need to make sure I have a subtraction, which I do. Now, I'm really going to look for things that are being squared here. Right? So there's the two things being squared, and they are being subtracted. So this is going to be another difference of squares. Now, when we actually go to start taking the square roots of things, there might be a little bit extra to think about. So if I take x minus 2 whole thing, and it's being squared, that means the square root of it is, x minus 2. If I take the square root of the last term, which is y minus 6, that is, it's y minus 6 squared, and when I square root it, I get y minus 6. There we go. So there's my square roots. Now inside, one has to be a plus, one has to be a minus. No different really than what we did before, just a nested expression to think about. Now I can get rid of my brackets, x minus 2. Since it's a plus sign, I don't have to worry about any of the signs, so plus y minus 6. This is my x minus 2, but here, since there's a negative, remember the distributive property applies. So negative y and plus 6. Collecting some like terms is going to leave us with an x plus y minus 8. Right, the 2 and the 6 can go together. And second factor, x minus y plus 4. Negative 2, positive 6, make a plus 4. So there we go. Still factorable using the difference of squares rule. Now you could have introduced a middle term. Very, very awful, and we won't even talk about it, but absolutely difference of squares exists and works here. Okay, now you can try C, D, and E out for yourselves and see how you do with those. Underneath, let's talk about a different type called a perfect square trinomial. So these are going to look very similar like those trinomials we did in the last couple lessons, but this is going to be, if I took the tiles out of this and actually drew a picture, it would actually form a square instead of a rectangle. And we're going to recognize this for a couple ways. Okay, first term is a square. Okay, so x squared is absolutely a perfect square. Last term is a perfect square as well, right? 4 is the same thing as 2 squared. Now in order to get that middle term, we're going to take the square root of the first term, so the square root of x squared is x. We're going to square root the last term, square root of 4 is 2, multiply them together, and then double it, right? So x times 2, x times 2 is here, and we're going to multiply them together, and then we're going to double it, because we essentially are going to have the same two groups of x's. So if you draw this out to really see what it looks like, I know the video is blocking it right now, so if I really draw this out, x squared plus 4x plus 4, right? There's x squared, 4 x's, and my 4 1's. Okay, so the reason why we're multiplying them together and then doubling it, really this is x and a 2, x and a 2. So here's my x squared, square rooted to get x by x. My 4 1's square root to get 2 by 2. Right, and that's why we're doubling, because there's two groups of x's that are the same, right? 2 x's in each group. And that's what we're doing here. So if I actually take a look at the example that they've provided, right, if I take the square root of 4, I get 2. Square root of x squared, I get x. And it's going to be the same factor again, because if I do 2 times x times 2, I land in that middle term of 4x. So let's take a look at a few of them. Even if you don't remember that it's a perfect square trinomial, you can still factor it using all of the other rules. Just know that your two factors will be the same. Right? So if I take a look at this one, square root of 25 is 5. Square root of x squared is x. So let's take a write down of that. So square root, oops, let me change this to black, change the size there. Okay. Square root of 25 is 5. Square root of x squared is x. So 5 times x is equal to 5x. But then if I double it, as long as I get my middle term, this is a perfect square trinomial. So I've got 10x from doing that, and yes, this does work. Oops, sorry, I keep blocking that there. There you go. So square root of 25 is 5. X squared is x. X times 5 is 5x. Doubled is 10x. So I'm going to have two groups of 5x. Okay, so that means my factors are going to be x plus 5 and x plus 5, right, for an x plus 5 square. Okay. Now, you could absolutely figure out two numbers that multiply to 25 and add to 10, and they would definitely be 5 and 5. And you could do this the same way. Okay, no different. Just might be a little bit shorter if you remember just the rules here. So let's take a look at b then and see if this changes. Now I've got a squareds and b squareds to think about. So if I take the square root of 36b squared, I'm going to get 6b. Okay, it's a perfect square. Square root of a squared is going to be a. So 6b multiplied with a is 6ab. If I double it, we're going to see we end up with 12ab, which is exactly what's in the middle. So now I know that I'm going to have a group of 6ab. If I split up my middle term by decomposition, the two things will be the same. So it'll be 6ab plus 6ab. This means it's a perfect square trinomial. So we're going to have two factors again, a plus 6b, a plus 6b. So this as a perfect square, a plus 6b squared. right? Exactly the same. You could do decomposition here as well, but since this is true and I actually get that middle term when I multiply the first and last square roots together and then double it, I can use the shortcut. Okay, we'll do one more just to see if anything changes with the number in front, and I'll leave the last one for people to try. So if I take a look, the square root of 4x squared is 2x. The square root of 9 is equal to 3. Okay. 2x times 3 is equal to 6x. Times 2 is 12x. I've got a negative 12x in here. Now that doesn't really change anything. It just changes what sign of 6x actually becomes. Because if I do 6x and 6x, if I add those together, I get positive 12. But if I do negative 6x and negative 6x, those add together to give me negative 12. Multiplying them together actually gives us the same sign of, 36, positive. So I really need to make sure it's negative is what we're going to do. Now, it makes it a little bit tricky to actually do this with, my 4 being there. So if I just take a step back and actually think about what will happen. Right, I had a 2x because of the square root of this one. All the other ones were just x's or a squared. So if I actually go to factor this one out, now it just won't be an x in the front. I know that there's actually a 2x in front that comes from that. Okay, so 2x and then the square roots. If I do my constant, it's going to be 3, because all of the other ones, I had my number, square root of 25 is 5, that went in, square root of x squared, that went in. Here, this one worked as well, so 36, I had my 6b went in, square root of a squared, my a went in, so here's no different. My 2x will go in, my 3 will go in. Okay, so 3, 3. And both the signs coming from here, so minus, minus. Okay, 2x minus 3 squared. So let's double check, make sure we did this right. So underneath, we're just going to do a little double check, just to make sure that we're still on the right page. So if I do my 2x minus 3 and, my 2x minus 3, we'll do just a little bit of distribution to double check how we did. So we're going to have a 4x squared, here to here, minus 6x when I do my second arrow. Okay, again, I put in a 3. All before, we were using whatever it was we got from actually doing the multiplying together. Okay, so here, 2x times 3 is actually 6x. But this one is a little different because of that coefficient not being 1. Okay, so I'm actually using the square root here. Okay, minus 6x again, and then plus 9. So really, this still works out to be my minus 12x plus 9. Exactly the same original expression, but a little bit different. Okay, so in red, I got exactly what I wanted. The method here, a little bit different than some of the other ones, because again, if I just look above, I square rooted 25 for 5, that went in, square rooted x squared for x, that went in, right? Really no different, but just make sure that we remember the coefficient of that x squared is not 1. So something else just to make sure and think about. Okay, I'll leave D for people to try. Underneath, we can factor some stuff that has 2 variables again. So we did talk about this in the last couple. As long as the variables on the middle term are a combination of the variables on the first and last term, you can try to factor this as a regular trinomial. So I'm going to do A, and I'm going to let people try out B. So here, we're again going to treat B like it's part of the constant. Okay, treat it like it's part of that. And the B in the middle, treat it like it's part of the 7. So you're going to take your 2 and your constant, because this is what we did to figure out what we multiply and add to. So we're going to multiply to a 6b squared, but we're going to add, we're going to add to negative 7b. So we're going to think about all the things that multiply to 6, like 1 and 6, and then 2 and 3. And we're going to recognize that 2 and 3 won't ever add to 7, so it's got to be some combination of 1 and 6. And I have to think about the b's as well. I want to add to a negative, multiply to a positive, so both are going to be negative. Now for the b's, I'm going to have a negative 1b and a negative 6b. As long as I can figure out the numbers, the b's just get attached. So think about actually multiplying this. B times b is b squared, negative times negative is positive, and there's a 6. So it does multiply to 6b squared, and it definitely adds to negative 7b. Now we can use your decomposition just like before. So 2a squared minus ab minus 6ab's plus 3b squared. So my 2a squared minus ab is in brackets. Here's my minus sign this time, so again, be careful of the brackets and what your signs become. So 6ab minus 3b squared. Common factors of a comes out, so you're left with a 2a minus b minus, that common factor here is 3b. 3b. Here we're going to have a 2a minus b. And again, your goal is to make those brackets the same, which they are. So your end result, your product, your binomial factors, 2a minus b, and then a minus 3b. Okay, so there you go. It is factored. There's the length and width of this rectangle if we were to represent it in tiles. So again, you're going to try b out, and you can check the answer key as well to see how you did. So that's basically all the factoring stuff that we could possibly talk about. Okay, we did trinomials, binomials, greatest common factor, two variables, difference of squares, a lot of different techniques that we can use, but all of this factoring stuff becomes super, super important for Math 20, Math 30, regardless if it's Dash 1 or Dash 2 really, because there's a lot more application that comes out of, you know, the graphs and all of their features. So the factoring stuff really, really important. So try as your best to keep up with it, and ask your teacher for all of the help that you need. You again can reach out to me on Twitter, Instagram, send me an email if you need anything. I'll be more than happy to help you out. So again, I hope these are helping, and we will see you, I guess, in our next unit, linear equations. So take care, stay safe.